Namaste, dear students. My name is Brijesh Mehta and I'm your chemistry mentor. Right, let us proceed ahead with our chapter, some basic concepts of chemistry. Right, these are very useful terms I'm going to teach you today. And in chemistry, we frequently come across symbols and formulae, right? So let us define what are symbols and what are formula. Chemistry is full of symbols and formulae. The abbreviations means short notation, short form. The abbreviations used for lengthy name of elements are termed as symbol, right? So this is carbon, right? So if we write carbon, this is very tedious to write, C-A-R-B-O-N, carbon. So instead of carbon, we have the symbol for carbon, and that is C. Similarly, for nitrogen, we have the symbol N. So it is very tedious to write these lengthy names, and instead we have short notations, which is called symbols, right? So a symbol represents one atom of an element, right? Symbol represents one atom of an element, single atom of an element. As you know, elements are made up of atoms. So when you write C, it not only stands for carbon, we come to know that we are talking of carbon, but it also represents one single atom of carbon. When you write N, we mean that it is nitrogen and it stands for one single atom of nitrogen, right? So a symbol represents one atom of an element and is usually the first letter of name of an element. Carbon starts with C, so first letter is C. Nitrogen starts with N, so the first letter is N, right? But as we have discussed in one of our previous videos, that many times many elements start with the same initial, same letter, right? Like calcium, cobalt, copper, cadmium, and carbon. They all start with C. Okay, so we have allotted the symbol C for carbon. For calcium, it is Ca. Usually the second letter is taken. So whenever we have a two-letter symbol, the first letter is always capital and the second is always small, right? So for cobalt, we have capital C and small o. For copper, we have Cu. Now why U? There is no U in the spelling of copper. So cuprum. So the symbol is derived from Latin name, right? For copper, it is cuprum, and from cuprum we have Cu. For cadmium, we have already taken Ca for calcium, so we write Cd, right? So suppose sodium. The symbol of sodium is Na, and Na is derived from natrium. Okay, this is from the Latin name. Sometimes it is Latin, sometimes it is Greek, sometimes it is German origin, right? So from the word natrium we have Na. So if you are not well versed with the symbols, then it happens that sodium starts with S, so you may write S. But S is symbol of sulfur. So you need to remember that sulfur is S and sodium is not SO or S, it is Na, right? So a symbol represents one atom of an element and is usually the first letter of name of the element. When two or more elements begin with the same letter, another letter is added to it in order to avoid confusion. The first letter is always capital and the second is always small. A symbol not merely an abbreviation for name of an element but has a quantitative. Now this is a word that you may have come across first time in our lecture. We have these two words, qualitative and quantitative. Qualitative means what and quantitative means how much. Now air is a mixture of nitrogen gas, oxygen gas. There is a lot of nitrogen in the air. Nitrogen is abundant as compared to oxygen. So that is the qualitative thing. Okay, we just say that what is present in air. Okay, but quantitative means how much. Nitrogen is 78 to 79% by volume of air. Okay, out of the total number of molecules of the air, 78 to 79%, roughly 80% you can say, 4/5 of the air is nitrogen. 20 to 21% of the molecules of the air are oxygen. Okay, so 4/5 is nitrogen and 1/5 is oxygen. So that is the quantitative idea. So qualitative and quantitative, these are two things, two words. So a symbol not only merely means not only an abbreviation, short form for name of an element, but as a quantitative significance. Significance means importance. Significance means importance as well. As we have already described here, when you write this, it not merely indicates that we are talking of carbon, but it also represents one atom of carbon, right? So thus O stands not only for an atom of oxygen, but also for 16 parts by weight of it. This weight being atomic weight of oxygen. We will make entire video on atomic weight later on in this chapter. So just forget about what is this 16 parts by weight. Okay, so it has quantitative significance as well, not only the qualitative significance. Now we have already talked, but this is important, so I have taken it again, that when you write symbol of any element, the first letter is always capital letter and the second is always small letter, right? Uppercase and lowercase. So when you write capital C and small o, it means the element cobalt. We are talking of cobalt. But when we write capital C and capital O, this capital C is carbon and this capital O is oxygen. So this is symbol of an element, but CO means the compound carbon monoxide. Okay, so instead of C and capital O, if you write C and small o for carbon monoxide, it will be incorrect. And whenever you are writing symbol of cobalt, if you write capital C and capital O, then also it is incorrect. So make sure that where you have to use capital letter and where you have to use small letter. And this symbolic expression for a molecule is called a formula, right? So H2 represents one molecule of hydrogen, and one molecule of hydrogen consists of two atoms of hydrogen. So H stands for atom, and when we write 2, it means 2 hydrogen atoms, and these 2 hydrogen atoms make one molecule, right? So this one is molecule and this 2 means atoms. This is called subscript, right? We have already talked earlier, this is called subscript, right? So when we write 4Cl2, okay, if you say such things anywhere, 4Cl2, so this Cl2 stands for molecular formula of chlorine. Molecular formula of chlorine is Cl2. Cl is symbol, it represents one atom. When we write 2, it stands for molecule. So this means 4 molecules. 4 molecules of chlorine, and each molecule contains 2 atoms. So this is one molecule, this is another molecule, this is another molecule, this is another molecule. All molecules have the same formula, right? So when we write 4 molecules, in all it makes 8 atoms, right? So 4Cl2 represents 4 molecules of chlorine. Each molecule of chlorine contains 2 chlorine atoms, as chlorine is diatomic. We already have seen diatomic means 2 atoms. So in all, 4Cl2 represents 8 chlorine atoms. So you must be aware of these things. Then we write 5CO2. Now CO2 is carbon dioxide. Carbon dioxide, right? Carbon dioxide. Oh, so let us. Carbon dioxide. Formula of carbon dioxide is CO2. Di means two. Dioxide means two oxygen atoms. Carbon dioxide. This is molecular formula. This is symbolic representation of molecular formula of carbon dioxide. It means that carbon dioxide molecule consists of one carbon atom connected to two oxygen atom, right? We have one carbon atom and two oxygen atom in carbon dioxide. So when we write 5CO2, it stands for 5 molecules of carbon dioxide. This is one molecule of carbon dioxide, and when we write 5, it stands for 5 molecules of carbon dioxide. So each carbon dioxide has one carbon atom and two oxygen atoms. So can you let me know how many carbon atoms are present in 5 molecules of carbon dioxide? Obviously 5 carbon atoms. And how many total number of oxygen atoms are present in 5 molecules of carbon dioxide? It is 5 2s are 10, right? So if we write CO2, one molecule, this is another molecule, this is another molecule, this is another molecule, and this is another molecule. Those who are weak in calculation and maths, for them I am writing this. So those who don't understand what I am doing here, these are 5 molecules of carbon dioxide. Okay, so if we count one carbon atom, 2, 3, 4, 5, right? So each person has one head. So if I say I have 5% here, then how many total number of heads are there? Obviously it is 5. Now each person has 2 legs. So if I say I have 5 people around me, then how many total number of legs are there? So it is 5 2s are 10. Similarly, this is one head and 2 legs, something like that. So when we write 5 molecules of carbon dioxide, each molecule has one carbon atom. So we have 5 carbon atom in all. And each molecule has 2 oxygen atoms, so 5 molecules have 10 oxygen atoms. So this counting will be required later on when we'll balance equation. A formula is a quantitative or weight significance also. As I've said, we'll see later on atomic weight and molecular weight, right? Atoms have weight. Weight is due to atoms. Matter have mass, and that is due to atoms in it, right? So that we'll see later on. Looking at a formula, we at once understand the ratio in which various atoms are united to form a molecule, which the formula represents. So when we write CO2, it means that the number of carbon atoms to number of oxygen atom is in the ratio 1:2, right? When we write formula of water H2O, it means that water contains hydrogen and oxygen atoms in the ratio 2:1. We have twice the number of hydrogen atoms as compared to oxygen atom, right? And finally, if I write C6H12O6, then you can say that, let me change the color. You can say that this is glucose. This is also fructose. If you have heard the name, fructose is fruit sugar, glucose is blood sugar. So glucose, fructose and galactose, these are 3 sugars having the same formula, C6H12O6. So seeing the formula, you can say we have equal number of carbon and oxygen atoms and we have twice the number of hydrogen atoms. So if someone asks you the ratio, it is 1:2:1. 6:12:6 is 1:2:1, right? So looking at a formula, we at once understand the ratio in which various atoms are united, bonded, united means bonded, to form a molecule which the formula represents, right? So this is what the formula represents. What is atomic number, right? The atomic number is also called proton number. Its symbol is Z of a chemical element. Atomic number is the number of protons found in nucleus of every element. Okay, now later on we'll study structure of atom. Those who don't know, atoms, we have found that atoms have a small positive charge, okay, in which the protons are packed, okay, and then electrons are moving in various orbits around it, right? This is very raw and preliminary understanding of structure of atom. So we have a nucleus at the center. Ernest Rutherford was a scientist who found that nucleus is present at the center of each atom. The nucleus contains number of protons in it. So number of proton is called atomic number, and that is unique for each and every element, right? So hydrogen atom contains 1 proton in its nucleus. Helium contains 2 protons inside the nucleus. Lithium contains 3 protons, right? Carbon contains 6 protons. Nitrogen contains 7 protons. Oxygen has 8 protons, and these are called atomic numbers. So atomic number is the number of protons. So previously I have told you to remember periodic table. Hydrogen is first element, its atomic number is 1. Helium is second element, its atomic number is 2. Lithium is third element, its atomic number is 3. Beryllium is fourth element. Boron is fifth element. Carbon is sixth element. Nitrogen is seventh element. Oxygen is number 8 as it has 8 protons, and so on. So atomic number is the number of protons found in nucleus of every atom of that element. The atomic number uniquely identifies a chemical element. What does this mean? Different elements have different number of protons. So if the proton number change, element will change, right? So it is unique for each and every element. No two elements have the same, no two different elements have the same number of protons inside the nucleus. It is identical to charge number of the nucleus. Now nucleus contains protons. Nucleus contains protons and neutrons. Protons are positive charge and neutrons have no charge. Okay, remember that protons have positive charge and neutrons have no charge. So it is identical to the charge number of nucleus. The number of charged particles means protons inside the nucleus is atomic number. In an uncharged atom, the atomic number is also equal to number of electrons. Now, see, atoms are electrically neutral. Atoms are electrically neutral. It means that the total positive charge is always equal to total negative charge. So the number of protons are always equal to the number of electrons. Okay, so suppose if we have 3 protons, then we will have 3 electrons revolving around the nucleus, right? So total positive charge is always equal to total negative charge, and atom is always electrically neutral, right? So with this I'll end this session, and I request you to remember name of elements as per their atomic number in sequence, right? You need to remember this thing, and it is very important, right? Hope you are enjoying my classes, and join edge.in for more such videos.